Okay, in this video, it's basically going to be part one of a two-part video. This one, we're going to look at making a stem and leaf plot, and then in the next video, we're going to look at a box and whisker plot. And so, basically, a stem and leaf plot is a way to kind of arrange data and see how data is distributed or the range of data is distributed based on stem and leaf. Kind of sort of similar to a histogram, but in this case, the data is more distributed by the stems and leaves based on place value, really, is what it is. So if you look at this data set here, actually I have some steps over here, and then here's the data set for commute to school. So we've interviewed some students. We've asked them how many minutes does it take you to get to school, and so these are the minutes that it takes people to get to school. And so the person who lives the closest or the least time is the shortest time is 3 minutes, and then the longest commute that students have is 32 minutes. And so we want to figure out, well, that's the smallest and the greatest, but is there a lot of people that have a shorter, or are there a lot of people that have a shorter commute or a longer commute, or so a lot of them in the middle, and just to see how the data is distributed. So in this case, 3 minutes and 32 minutes, again, we do it kind of by place value. So we have data in the tens place and the ones place. So I'm going to make my stem the tens place and my leaves the ones place. And so one thing that we need to do is make a key, okay? And I'm going to say my stem, for example, if my stem is the tens place and my leaves are the ones place, then 3 line 2 means 32. Now, if I had data like 3.5, right, and 1.6 and these kinds of things, then maybe my key would be the 3, 5 would represent 3.5. You can see how the stem then is the ones place and the 5 is the tenths place. And then you can do it for hundreds and those kinds of things. So I'm going to say my key is using the tens place and the ones place now. And so I'm going to, I identify my stems and I made a key. Now I'm going to make an unordered stem and leaf plot. And so I'm going to just very briefly make this data. Now, I said my smallest value was 3. So in the tens place for the number 3 is actually 0, right? And then I have 1 for 10, 11, 12, and so on, and then a 20-something, and then a 30-something. Those would be my stems. Now I'm going to go through this list, and this is an unordered stem and leaf plot at this point, and so I'm just going to go through so I don't miss any one at a time. And so 5 is 0, 5, so I'm going to put the leaf of 5 with the 0, 5. Then I'm going to cross that off. By the way, well, we'll get to that in a second. At the end, I'm going to count how many numbers I had in my data set and then how many numbers are on my stem and leaf plot to make sure I didn't miss any. So 0, 5 on 1, 13 is 1, 3, okay, 9 is 0, 9, so I'm going to put a comma here to separate those numbers. 31, 25, 21, and again, this is unordered, so I'm just going to write them just as they come. Okay, so again, let's see. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I got them all. Okay, so this again is 0, 5, 0, 9, 0, 3, 1, 3. That's 13, 18, 14, 11, and so on. So this is an unordered stem and leaf plot. I have my key. Now I'm just going to rewrite it, putting it in order, and it's a lot easier to do it this way than trying to order it or I think so anyway, and trying to order it straight from there. So I just need to rearrange these to be 3, 5, 9. And then I can rearrange this to be 1, 3, 4, 6, 8. This is going to be 1, 2, 3, 5, 5, and 1 and 2. By the way, you could do this. You could do this if you wanted to, if you thought it made it easier to do mean, median, mode, or range, because now you have them all listed here. And you could say, well, if we're trying to find the median, let's say, here's 0, 3, and 32, and 5, and 31, and 9, and 25. And you could find the middle that way. And again, we will do that when we do the box and whisker plot. But here is my now ordered, don't forget the key. By the way, it doesn't have to be the biggest number. It could be 21 equals, 2/1 equals 21, but I'll just leave it like this. Okay, so we make an ordered stem and leaf plot. And that is really the summary of stem and leaf plots. Okay, as I said in the next video, we'll take this data now and we'll make a box and whisker plot with it.